are all well. In this lecture, we will continue to work with Matplot library and focus on histograms, pie charts, and group bar plots. Let's start out with a warm-up question. So last time we used plot function, subplots to create several graphs in one window. Now let's write a code which creates 4 plots in one window. So we are going to use subplot functions. The X data set should be between 1 and 2 times pi and a space equal to 0.01. So they are evenly spaced. First plot shows the relationship between X and sine of X, and the color of plot is green. Second plot shows the relationship between X and cosine of X, and the color is red. Third plot shows the relationship between X and tangent of X, and the color is blue. And the last plot shows the relationship between X and logarithm of X, and the color is green. Okay. First, we import Matplot library that we use for visualization. We assign PLT as a nickname because we want to calculate some functions applied to all elements. Then we use arrays as a data structure. So we import numerical Python package as np. Then I use the subplot function. So PLT subplot, number of rows 2 by 2, so 2 rows, 2 columns, and then this is the index for the first graph. PLT plot, then we need to pass X and Y. X is t, and np.sine of t, and the color is green. Define P, I use the arrange function between 1 and 2 times pi. np.pi. The third argument 0.01. Let me print t to make sure. Okay, so it's an array. Okay, points. So the step value is 0.01. Let me run it. Okay, here we go. Then I can assign the X label, Y label. So PLT dot X label. Let's say it's T. PLT dot Y label is sine of T. Now we can define the second graph, but first we call the subplot again. Subplot 2 by 2, the index is 2 in the second position. Then we use the plot function. We want to show the relationship between t and cosine of t. And the color is red. Then we define x label, which is again t, y label is cosine of t, and then we can draw another plot. So plt.subplot two by two, the index is 3. Then we call the plot function, which is the relationship between t and tangent. So np.tangent of t. Then we add x label and y label. Then we call subplot for the last graph. So plt.subplot. Two by two, index 4. Now we can plot the data, which is the relationship between t and logarithm. So np.logarithm of t, and the color is green. I think here we can define the color. Blue. Color is green. And then we define the x label and y label. Then we can show the plot. Let's run it. Now you can see this graph. The first one is sine, the color is green. Other one is cosine, the color is red. The third one, tangent, and the last one is a logarithm. So 4 graphs in one window. Okay. So this was just a warm-up. But in this lecture, we want to work with histograms. Histograms are single variable charts that show frequency or density of the values in each range. We can use histogram as an accurate representation of the distribution of numerical data. You might remember from statistics, if we want to find empirical distribution, first we'll look at the histogram. So it is an estimate of the probability distribution of a continuous variable or quantitative variables. Histograms can be generated with a number of different options in Python. So we have a list or an array because it's just for a single variable. We import the library. We define the data. In this example, y is our data set, which is a list. And then we call plt.hist, which is a histogram. This is a function. Then we pass the data, and then we define number of bins, number of bars that you have in your histogram. Then you assign x label, y label, and then you show the plot. So everything we discussed about formatting graphs applies here. Instead of plot, we just use histogram, which is hist. So bins is a second argument that we can pass when we want to draw a histogram. It takes integer, sequence, or a string, and it's optional. If bins is an integer, it defines the number of equal width bins in the range. So if you remember from a statistic, the number of bins or classes is approximately equal to a square root of the data points. So if you have 20 data points, the square root of 20 can be the number of bins. So let's implement this in a notebook, and then we can see what it looks like. To make sure we don't make any typos, let me copy y variable. Here it's a list, data points. So we call plt dot hist, which represent histograms, y, and bin is optional, but we want to have 5 equally width classes. And then plt x label, let's say category, and then y label is frequency. Let's run it. There is a rectangle object, no, so it should be, I think it should be bins. Okay. Now this becomes the histograms. Now if you change this, let's say with 3, then that's the histogram. Or if you change it to 6, then you can see what it looks like. Okay. Oftentimes we want to compare several histograms. So we want to compare them. This can be done with a stacked or side-by-side plots in Python. If you want to go with the stack variable, we pass the data in a list. So x1 is the first variable, x2 second variable, x3 third variable, so it becomes like a list of lists. And then we pass this to the hist function. And then you set a stacks true. It means that now you want to go with the stacks option. But if you want to show it side by side, we present the data in the list in plt.histogram. So you're going to see an example. We can also plot densities. Density plots can be used inside of matplot figures. These plots are a smoothed, continuous version of a histogram estimated from the data. So for density plot, we use another library called Seaboard. So we need to import a new library, as you can see here. This library also produces some nice visuals. We can use it for regression models and later on. So it's another library which has some visualization related functions. So to do that, if we want to show density plots, so first we call Seaboard, we assign SNS as a nickname, and then the function is distribution plot or this plot. Now, if you want to go with histogram, so histogram with his equal to true, then it represents a histogram, very similar to what we had before. If you want to go with density plot, then KD equal to true. By default, both are true. We can also fill in with shade. So shade equal to true, and then you fill in the density plots. So you are going to see an example, then it makes sense, makes better sense. So in this example, we want to create a random data set of 2 columns and 1,000 rows. So let's say we have 1,000 observations and 2 variables. Now we want to plot a 2x2 figure. So we are going to use subplot. Top left, side-by-side histogram of the first column versus second. So we want to compare 2 histograms side by side. Top right, a stacked histogram of first column versus second. So you can see the difference. Bottom left, density plot and histogram of the first column. So we want to have both for the first variable. And the bottom right, density plots of both, no histogram. So it's a good practice. Then we can use all the functions we just discussed. Okay. First, we import Seaborn library as SNS. Then we create the data, which is np.random. I use randn function from a standard normal distribution. Size is 1000 by 2, so each column represents one variable. Then I define a figure object by plt.figure. So it's an empty figure, then we need to fill in with data and other attributes. So the first one, ax1, is equal to, I call the feed variable, my object, dot add underline subplot. Two by two, first position. So first we apply the hist function. Then, because we want to have both variable, then we have list of lists. The first list, data, all rows and first column. Make sure that it is the square bracket. Then the other data is all rows, second column. Seems that we need another. Okay. Now I can add another graph, ax2 equal to, I call figure object, then add underline subplot. Index is 2. So it is histogram, but it is the stacked version. So plt.hist the first variable is data, all rows, first column, then data, all rows, second column, then stacked is equal to true. Now I can create the third graph. So fig dot add underline subplot. 2 by 2 index is 3. Now here I need to use a distplot function. So first we call the Seaborn library, then distplot function, and the data is the first column. Another graph is fig.add subplot. we update the index, which is 4. Then we call Seaborn library, again, this plot function. Then the data is first column, and then his is false. We call the Seaborn library again, the same function, but this time for the second column. His is also false. So let's run this. Probably there is a, must be 2. Okay, there is another typo here. Let me run it. Okay, here we go. So now you can see 2 histograms on top left, then the stacked version, and the third graph top bottom left is actually both the density plot and the histogram, and then the last one is the 2 density plots for your data, which looks like a bell-shaped curve, because we use the rand_n function, the standard normal distribution. So we do expect to see some bell-shaped curves and histograms. Okay. And here you can see the codes, what we just discussed. So with that, I move on to pie chart. Pie chart or circle chart is a circular statistical graph which is divided into slices to illustrate numerical proportion. So you might see pie charts in business meetings a lot, because when you want to present statistics related to fractions, proportions. So it can be very useful in meetings. It's simple, but it can convey important information. It's named for its resemblance to a pie which has been sliced. Now, in this slide, you can see one example. So we use Seaborn library again and Matplot library. I define a variable, which is a list text label, because we want to assign it to each slice. So you can see we have 4 categories. So we have 4 names for each slice. Then another variable, which is a list, which explains the proportion, percentage. So 45%, 30%, 15, and 10. So make sure that the summation is not greater than 100%. Then I define another variable, which is the offset. So if you want to emphasize on a single slice, then you can change the offset values. So you are going to see what it looks like. Then we call Matplot library, and the function is named pi. Then we can pass fraction, the proportions, and we use explode to offset slices, and then we pass labels. And if you want to show percentage of each slice, then we use auto PCD or auto percentage. And 1.1, it means that 1 digit after decimal point. The other argument is the start angle. So here a start angle is 90 degrees. And you can define colors. So here, to define colors, we use color palette under Seaborn library. And there are different color themes. We go with muted. And then we show the result. Before I implement this in a notebook, let's look at some notes. I have tried to explain the arguments we passed for pie charts. Current underline palette. There are 6 variations of default theme, so you can go with deep, muted, bright, dark, and other options. So, offsetting a slide with explode, so you are going to see what it looks like. And if you want to show the percentage in each slide, we need to pass the auto PCD argument. Now let's implement this in a notebook and you can see what it looks like. First, we define the text label, which is a list of strings. So let's say cats, in this example dogs, then frogs, then others. Another variable which shows fractions, so 45, 30, 15, and 10%. Offsets, let's say we want to emphasize on the second category, dogs, so 0, 0.05. And then I can call the pi function on their plot PLT library. We pass fractions, explode to offset slides. Then labels, which is the text labels we just defined. And then the auto percentage. This is the formatting, so 1.1. The other argument is a start angle. Let's say it's 90, you can change it to 0 if you want. And then for colors, we use Seaborn library dot color underline palette. Let's say we go with muted option. Then we can show the pie chart. Let's run it. Okay, there is a typo. A start angle. Now this becomes the pie chart. Okay, so there are 4 categories with their percentage, 1 digit after decimal points, and you can see the offset. So here we wanted to emphasize on this slice 30%. Now you can, that's why we passed the explode argument. Now let me just go with like 1. And if you run it, you can see how far this slice is from the rest of the graph. You can also change the color palette, the starting angle, and etc. Group bar plots, also another useful visualization technique to summarize several variables in one graph. Group bar plots present data with rectangular bars with heights or lengths proportional to the values that they represent. If you want to compare 4 products, for example, you can use group bar plots in one graph. So because we have different variables, so we can use a data frame as our data structure. So pandas.data frame, I generate a matrix 10 by 4. So each column represents one variable. So we have 4 columns, A, B, C, D. And we just simply apply plot function. The only thing we change is the kind. So plot kind equal to bar, and then we can show the result. Let's see what the results look like in a notebook. First, I import pandas because data frame is our data structure. Then I create the data, which is pd.data frame. I use the rand function, which generates random number between 0 and 1. Size is 10 by 4. Then we pass columns, a list of 4 strings. And then we just use the plot function. The only thing we change is the kind, so it's now a bar. The grid is false in this example. If we run it, you can see. Okay. So for each row, 0, 1, 2, 3 to 9, then you see 4 bars, which represent the 4 variables, and you can see the legend A, B, C, D. Now, you can transpose this matrix. You can make it 4 by 10, and then you will have 4 rows, and for each row, you will have 10 bars. Again, which one is the right way for your data is based on the context, and you should decide which one is appropriate for your data and what message you want to convey to the audience. So we have another example which gives us some context to this. Okay. So this is our practice problems, 3 of them, and it summarizes main points we discussed in this lecture. For the first one, we want to create 500 random numbers between 1 and 100 and show them on a histogram with bins equal to 10. We also talked about the pie chart. This time we have several categories, 8. And then we want to show the following table in a pie chart. And the last one is a group bar plot. There are 8 different types of products. 10 numbers are assigned to each type, representing 10 characteristics of each product. These numbers are random integers between 20 and 150, show the frequency of each type in each bin. Now, that's the part that we should decide. Do we want to visualize each characteristic or to compare products based on different characteristics? So at this point, I encourage you to pause the video, try to create these plots, and then compare your results with mine. So for the first one, first I generate an array, one-dimensional array, because it's for histograms. So np.random.rand 500. So rand generates random numbers between 0 and 1. So I multiply by 100 to make sure that they are between 1 and 100. That's one way to do it. And then I can apply the hist function where number of bins equal to 10. I can add y label shows frequency. Then we can run it. So this is the histogram for the randomly generated numbers. For the second question, we have the pie chart. So I'm going to use some of the variables we have here and then modify those. Okay. So the categories are cherry. The other one is peach. Okay. Third category is apple. All type of fruits here. Orange. Blueberry. Raspberry. Strawberry. And grapes. Okay. Then fraction, which represent the proportions of all categories. So we have 5 based on the table, 12, 20, 25, 8, 7, 13, and 10. Then we have offset. So we want to emphasize on second category. So its value is 0.05, or we can go with 8. And the rest is 0. So 6 zeros here. Okay, that's the offset. And now we can apply the pi function. We pass fractions, explode, labels, auto percentage, 1 digit after the decimal point, start angle. So we can change it to 0 this time. And colors can be muted. And we can run it. So you can see that offset variable is applied to the peach category. We can see the percentage of each slice with different colors and 1 digit after the decimal point. And the starting angle is 0. So the first slice, cherry, starts from 0. Okay. So that's our pie chart. And the last question is the group bar plot. So first we generate the random numbers. Random numbers between 20 and 150. And the size is 10 by 8. So columns represent the type of products, and then rows present the characteristic of each product. And that's how I want to group the data. Okay. Generated, and then I want to create a data frame. Pandas.data frame. I pass Y, and then we need to define columns. I go with product A, B, C through H. Now I can apply the plot function. df.plot kind is bar, and this time grid is true, so we are going to see the grid. Let's run it, and this is our group bar plots. So we have 8 bars for each product, and we are compare them against different characteristics. Here, 10 characteristics. And with that, I wrap up our discussion.